Hi guys, back with me again, Adi Kurniawan Yusuf. In this video, I would like to share to you about two samples hypothesis testing. What is two samples hypothesis testing? So basically, it is a method to test the hypothesis to compare two set of data or samples. For example, is the weight loss on diet type A lower than that on diet type B? We want to compare the weight loss on the diet type A and also diet type B. The hypothesis will be, since the keyword here is lower than, so the H1 will be mu A is less than mu B. Therefore, the HO will be mu A is more than or equal mu B. The second example is the score after training higher than that before training? We want to compare the score before training and also after training. The keyword here is higher. Therefore, the H1 will be mu after is higher or larger than mu before. Therefore, the HO will be the mu after is less than or equal than mu before. There are two common types of two samples hypothesis testing. The first one is independent sample. The second one is dependent or paired sample. Let's discuss independent sample. In the independent sample, we would like to compare two different sample means, such as we want to compare female and also male. We want to compare CTA and also CTP. The number of the samples between two data can be different. For example, I want to compare the financial literacy rate on the male students and female students. Perhaps you have 10 male students and you have 12 female students. These samples are different. Therefore, we call this as independent samples. The second one is dependent or paired sample. Dependent or paired sample is used to compare a sample in two different conditions. So here we have the same sample but the condition is different. Therefore, the number of the samples must be the same because the sample is the same. For example, I want to compare, is there any difference in the IELTS score before and after IELTS training? The sample will be the same people. Therefore, the number of the sample before and after training will be the same. That is dependent or paired sample. So, the samples are not independent. Do you get the point, right? These are the formula of two samples hypothesis testing. The left side is the formula of independent sample. The right side is the formula of dependent or paired sample. In the independent sample, we can use C-test and also T-test. C-test is used when both sample size is higher than 30 and both population standard deviation is known. When one of the requirement is not met, so we can use T-test. In the T-test, you can use the formula of equal standard deviation and unequal standard deviation. So you have to compare the standard deviation between two groups. Actually, to compare standard deviation, you need ANOVA, analysis of variance. But if you haven't learned about ANOVA, you can use this rule of thumb. If the ratio between larger standard deviation and smaller one is less than 2, we assume equal standard deviation or equal variance. Is it easy, right? You can also see the formula of the T calculation for T-test equals standard deviation or variance, and also the T calculation for unequal standard deviation or variance. One thing you need to pay attention, the degree of freedom. Degree of freedom of T-test with equal variance or standard deviation is N1 plus N2 minus 2. N1 is the number of sample of the first data, N2 is the number of sample of the second data. While for unequal variance or unequal standard deviation, the formula of df is provided. For dependent or paired sample, we can only use t-test. To analyze two-sample hypothesis testing, for z-test, you could not use SPSS, but you have to calculate it manually or using the Microsoft Excel. But for t-test, as long as the data is available, you can use SPSS. Therefore, in this video, I only would like to cover z-test, how to calculate z-test manually. While for the other, for t-test, both for independent and also dependent or paired samples, we will use SPSS in the next video. Before we go to the sample question, I would like to explain to you the difference between one-tailed test and two-tailed test. I will explain about two-tailed test first. Two-tailed test is used when the HO is equal, the H1 is not equal. It is used when we as the researcher want to know whether a sample mean is significantly different from other sample mean in any direction. The keyword here is only different. Different can be higher or lower. Actually, two-tailed test has lower power compared to one-tailed test because they spread the critical region across both tails of the distribution, right and left. However, one-tailed test is used when we want to know whether a sample mean is either significantly greater or less than other sample mean. It focuses only in one direction of the distribution. Therefore, it has higher power because they concentrate all the critical region in one tail of distribution. Heads up, if the conclusion in the two tail is different, it must be higher or lower. One more time, if the result in the two-tail is different, it must be higher or lower. But if the result in the one-tail is higher or lower, the result in the two-tail not necessarily different. Just to remind you, these are the steps to conduct hypothesis testing. If you want to understand more about hypothesis testing, you can watch our previous video about hypothesis testing. Let's go to the sample question. A business analyst seeks to conduct a hypothesis test to determine whether there exists a difference between the average annual salaries of advertising managers and auditing managers. A random sample of 32 advertising managers from various regions across Australia is obtained. These advertising managers are then contacted via email and asked to provide their annual salaries. Similarly, a random sample of 34 auditing managers is also collected. The salary data is listed below. Use 98% confidence interval. Well, since the keyword here is there any difference, so when we want to set the hypothesis, the HO will be mu advertising equal to mu auditing. The H1 will be mu advertising is not equal to mu auditing. The second one, we determine the significance level. In the question, it is stated that 98% confidence interval. It means the significance level will be 100% minus 98%. It is 2%. So the alpha is 2%. The third one is select the test statistics. Since the population standard deviation is known for both samples and the number of samples for both data is larger than 30, so we use z-test. Besides that, we will also utilize two-tailed test. The fourth one will be formulate decision rule. As we know in the two-tailed graph, if the significance level is 2%, in the right tail will be 1%, in the left tail will be 1%. So the white area in the half side of the bell curve will be 49%. We can find the Z critical using area 0.4900. We can find that the Z will be 2.33. Since we also have Z critical in the left, so the Z critical in the left will be minus 2.33. Therefore, the decision rule will be If the C calculation falls between minus 233 and 233, do not reject its O. While it falls outside minus 233 and 233, reject its O and accept its 1. This is the formula of calculating C for two-sample hypothesis testing as I mentioned previously. So the C will be the X bar of advertising minus X bar of auditing divided by the square root of standard deviation square, it is variance. The variance of advertising divided by N of advertising plus variance of auditing divided by N of auditing. Therefore, we can find that the C will be 2.35. 2.35 falls in the rejection area. Therefore, we should reject its O and accept its 1. We can say that the average annual salary of advertising and auditing managers are different using 2% significant level. How if I ask you about p-value? To calculate p-value, we have to use the C calculation, 2.35. If we see in the C table, 2.35, the result will be 0.4906. It means the p-value in one side only will be 50% minus 49.06%. It equals to 0.94%. Since we have two tails, therefore the p-value should be multiplied by 2. It will become 1.88%. Since the p-value is less than alpha, so we should reject its O and accept its 1. By the way, as I mentioned in the previous video, for the C critical, you can also use Microsoft Excel to find it. The next one, how if I change the question to be like this? Is the average annual salaries of advertising managers higher than auditing manager at 2% significance level? So we will use one-tail test because the keyword is higher. The HO will be mu advertising is less than or equal mu auditing, while for the H1 will be mu advertising is higher or larger than mu auditing, since the keyword is higher. The significance level as the second step will be 2% because the confidence interval is 98%. The test statistic we use, it is C-test because we know all population standard deviation and the number of samples are more than 30. But here we will use one-tail test. If in this case we use one-tail test, of course the C critical will be different. Because the keyword is higher, therefore the tail will be located in the right. The tail area in the right will be 2%, so the white area in the half side of the bell curve will be 48%. Using the C table or Microsoft Excel, we can find that the C critical will be 2.06. Therefore, the decision rule, if the C calculation is less than 2.06, do not reject its O. But if the C calculation is higher than 2.06, reject its O and accept its 1. The C calculation formula is the same, and we have found that the C calculation is 2.35. It is located in the rejection area. Therefore, we reject its O and accept its 1. The average annual salary of advertising managers are higher than auditing managers using 2% significance level. As I mentioned previously, if in the two tail it is stated different, in the one tail it must be higher or lower. It is impossible if in the two tail it is stated different, but in the one tail the result is not higher or is not lower. If you are asked about the p-value, we have calculated previously using 2.35, the area of the tail will be 0.94%. That is directly the p-value. We don't need to multiply by 2 because we only have one tail. And the p-value 0.94% is lower than 5%. Therefore, we should reject its O and accept its 1.